Good evening, everyone, and submitting my humble pranams to His Holiness Jagatguru Sri Shivaratri Deshakendra Mass Committee. I am Dr. M.P. Gaurav, Faculty, JSS College of Pharmacy, Mysuru, a Constituent College of JSS Academy of Higher Education and Research. It's my privilege to welcome you all for this webinar on 3D printing in healthcare during COVID-19 pandemic. I extend my warm welcome to Dr. B. Suresh sir, who will be joining us in some time. He is the President, Pharmacy Council of India and Pro-Chancellor, JSS, Academy of Higher Education and Research, who needs no introduction at all. He is an eminent educationist, pharmacist, and a true leader by himself. I welcome him, who will be in some time. I am highly honored to welcome Dr. Surendra Singh, Vice Chancellor, JSS Academy of Higher Education and Research. He is a doctor by profession and he has joined JSS Academy of Higher Education and Research in November 2019. He took over the charge of Drugs Controller General of India in February 2008 till November 2011. Dr. Surendra Singh was also the Director of National Institute of Biologics, which is under the Ministry of Health and Family Welfare, Government of India, which is the National Control Laboratory for testing of all biologicals, including vaccines and biopharmaceuticals. In his tenure, he has held various positions, accolades, and awards to his name. I welcome you, sir.
Thank you, Dr. Gaurav. Thank you.
I welcome Dr. P. Kushalappa, sir, who will be also joining in some time. He is the Director Academics, JSS Academy of Higher Education and Research, for always supporting in all our endeavors. I extend a pleasant welcome to our beloved Principal, Dr. T.M. Pramod Kumar, Principal, JSS College of Pharmacy, Mysuru, and he is also the group leader of Special Interest Group of 3D Printing in Healthcare, and it is his brainchild to start 3D printing in healthcare in JSS University. I welcome you, sir.
Thank you, Gaurav. Thank you.
I heartily welcome all the panelists and the speakers. I welcome Guru Prasad K. Rao, who will also be joining in some time. He is the mentor and director and is one of the speakers, Imaginarium India Private Limited. I extend a warm welcome to Dr. Ravi Shankar SN. He is the Managing Director, Accreate Additive Labs, for always supporting us. I welcome you, sir. Ravi Shankar, sir, I welcome you, sir.
Yeah, thank you.
Sir, I welcome our very own Dr. Shyam Prasad Shetty, sir, Associate Professor and Head, Department of Cardiothoracic Surgery and Vascular Surgery, JSS Hospital. I welcome you, sir. Lastly, a special welcome to all the guests and participants who have registered and participating in this webinar. I am very sure this webinar will be very informative. So coming to 3D printing, 3D printing in healthcare is one of the disruptive technology that is going to change the way drugs and devices are being tailored to an individual. And this webinar mainly focuses on understanding the role of 3D printing in life sciences, and it also gives an insight into readiness for adoption of 3D printing in India. And also it gives an expert's opinion about 3D printing application and their challenges. With this brief introduction, may I now request Dr. Surendra Singh, Vice Chancellor, JSS Academy of Higher Education, to give his inaugural remarks.
Thank you, Dr. Gaurav.
Thank you, sir.
Good evening to all of you. I'm very glad to be participating in this webinar on 3D printing in healthcare during COVID-19 pandemic, which has been organized by JSS College of Pharmacy, Mysuru. And especially I very much appreciate the leadership of Dr. Pramod. And this is being organized in collaboration with Special Interest Group of 3D Printing of JSS Academy of Higher Education Research. The core values of JSS Academy of Higher Education Research are derived from its engagements in high quality research and innovative teaching methods. To encourage interdisciplinary research, JSS Academy of Higher Education Research has started special interest groups comprising of members drawn from various constituent colleges and university departments. I've always been very impressed to see this amazingly talented faculty involved in these special interest groups And one such group is a 3D printing in healthcare. Recently, we had organized a webinar on artificial intelligence in healthcare in collaboration with our JSS hospital, which was very well attended. And what we found was that the medical industry, as we are all knowing, is very much advanced and is always at the forefront of developing new diagnostic treatment and prophylactics, as this our webinar on artificial intelligence brought it to the forefront. Similarly, 3D printing in healthcare is also similar to artificial intelligence and is a disruptive technology, which is again like AI proving to be a game changer in the treatment of patients and revolutionizing the healthcare services. This technology makes it possible for medical professionals to provide patients with new form of treatment in a number of ways. That is development of new surgery planning and drill guides, prosthetics, as well as creation of patient-specific replica of bones, organs, and blood vessels. Customized parts can be tailored to each individual's requirement. And this improves the understanding of patients by the medical professionals and also improves patient comfort level by allowing interaction with products that are designed specially for the anatomy of the patients. I'm certain this webinar will facilitate in the participants having a better understanding in the role of 3D printing in healthcare sector and would be a willing partner to see that this initiative of JSS College of Pharmacy and our SIG groups becomes a reality and a lot of new innovative products come out of this initiative. I wish the meeting all the success. Thank you.
Sir, thank you very much. And now, without taking much of the time, now we'll be starting with our first session. Now I invite Dr. T.M. Pramod Kumar, Principal, JSS College of Pharmacy, Mysuru. Dr. T.M. Pramod Kumar, more than 24 years of experience in academics, and he has published more than 120 publications to his credit. And without taking much of the time, I request Dr. T.M. Pramod Kumar to take over this.
Yeah, thank you, Gaurav. At the outset, good evening, everyone. I thank all our renowned speakers who have joined from Mumbai, Bangalore, and from our JSS hospital to be here with us to support this initiative of special interest group of 3D printing in healthcare. The journey started in 2017 when the university took the initiative of starting the special interest groups in various disciplines. And to tell you briefly about how did I consume, maybe I think we in the childhood days we saw by nature how the honeybee makes his bee and maybe the silkworm or even the insects construct their home. I think they're all 3D printing. They are master 3D printers themselves. And this interest was basically, I think I got it from the kitchen, where my mom was to make a chakli and all. I thought maybe that is one of the earliest 3D printing which influenced me. And as a team, though I am from the pharmacy background, we have the renowned doctors in our team. Am I audible, Gaurav? Okay. Medical device manufacturers we have medical device manufacturer like Vishnu Prasad Alva from Scanray. We have engineers, we have dentists, and we have the best 3D printing service providers like Accredited Labs and Imaginarium from Mumbai, who are our mentors and our guiding principles for all these new initiatives. They are the experts in India, I can say. And even for this 3D printing, we need to set our own goals for ourselves. Like we need to set goals for the 3D printing. As a short-term goal, we had goals set for conducting various seminars, conferences, and all. And also we thought going forward, we need to build the in-house strength like providing or starting a PG diploma in 3D printing, and also take up research activities and further go ahead with the research activities, 3D printing and with the bioprinting. As a long-term goal, we set ourselves to establish the 3D printing center of excellence of 3D printing in healthcare in particular. 3D printing itself is a big ocean. We have just chosen ourselves to be limiting ourselves for 3D printing. As a small initiative since the last 3 years, we have been making noise by conducting guest lectures, seminars, and to know myself about what this group is all about, to know what they are going to discuss and all. Even I started participating in various seminars, conferences, and user forum also. Then, as an outcome of this SIG group with a renowned people join hands together, the basic idea of JSS AHER was to start an interdisciplinary type of research, because of which this SIG groups have taken its birth. And with that initiative, we have also submitted till now 5 different projects of 3D printing at various levels, at the medical, dental, ENT, and even the surgical models also, to the worth of 23.5 crores. And already we have got a formal approval by the Director Academics of the university to start even the PG diploma in 3D printing. As I told you, I started participating in Stratasys 3D user forum, which from 2018, 2019 also I participated. I could meet renowned scientists over there. We have here Dr. Harvinder Singh Bedi, who is a cardiothoracic surgeon. He has used 3D models to the maximum and saved number of lives also. And you could also see our very close mentors and partners, Ravi Shankar and Sheshgiri and all. We met them in that user forum only. It was a good learning experience where I could connect myself to the different scientists. And in 2018, one of the institutions got a center of excellence, which Stratasys opened it up. Then I took that interest and I thought maybe next year who is going to get it. It was a university, Ganpat University. They started a 3D printing center of excellence at Gujarat, and we could meet a number of people over there. And as an outcome, we also started conducting seminars, workshops like Industry 4.0. We had Pharmaceutical 4.0, which we conducted last year, which was very successful. And Dr. Guru Prasad was kind enough to travel all the way from Mumbai and be here and did a live demonstration of 3D printing here. Thank you very much, sir, for all that initiative. And all the doctors participated, doctors and our SJC team also participated over there. And myself and Dr. Prashant took time visiting Accurate Additive Lab facilities, where they have the state-of-the-art facility, and they almost half a day we spent with them, followed with a wonderful lunch they served us over there. Thank you, Ravi Shankar, for all that initiative. It is not just lunch for us, even there was food for thought also, because we learned that mechanical engineers who are working, a young team who are working there, were having the book of Genong of anatomy, human anatomy and physiology. A book was also there with them. It means that interdisciplinary already they are learning over there. And going forward, I need not explain, the experts are here to tell us about how this technology is being used for the preoperative surgical planning, and how bone repairs can be done, and fabricating different biodegradable scaffolds also. And it was more interesting for me because there are a number of drug delivery systems where even US FDA has approved it also. And during COVID pandemic, there were a number of personal protection equipment that were developed. All the 3D printing scientists and the people who are working in that domain raised to the occasion where in India, it has been said that we did not have a personal protection equipment. In the today's newspaper, I was reading that PPEs to the tune of 50 lakhs they want to export from Coimbatore itself. So that is the capacity of what India has got it. So raised to the 3D printers have raised printing scientists have raised to the occasion, prepared a number of personal protection equipment so that they protect all our frontline COVID warriors and keep them safe and healthy also. So what I would say here is, as our Vice Chancellor and Dr. Gaurav was making a mention, certainly it is a disruptive technology where logistic industry may even be having a tough time, because I sit here and design and communicate by software to US to take a printout there. So whole of the logistic industry would not be required. And going forward, there may be a manufacturing of the body parts in the body shop. It is not a body shop of a automobile industry, but it is a body shop of the human body parts being made, and more by 3D bioprinting also. And earlier its limitation was it is only used for the prototyping, but now it can also be going for a mass production also, which was very evident in preparing some of the PPEs for the COVID frontline warriors. And certainly it has a great future in the health science, and even also in the food industry, where number of dishes are being 3D printed as well. And a new 3D printing material is also every day there is a research going on. New 3D printing material is also coming up. It is not just a 3D printing, it is already 4D printing also has come up, where that particular device or material is also responding to the external stimuli, or maybe even shape retaining memory forms also. So what I visualize is, by 2022, we want to see JSS AHER having its own center of excellence of 3D printing at our facility. And I am a big dreamer, and this should not let me go to sleep, but should always keep me going ahead. So thank you very much. I again take this opportunity for giving me an opportunity to be a part of this webinar. Thank you, Gaurav. Over to you, Gaurav. Unmute yourself. Yeah.
So the question and answer sessions will be taken at the end of all this.
Yes. That would be nice. That would be nice.
So, sir, and I would like to thank you, and definitely your dreams will come into reality. That maybe by coming years, we'll definitely have a center of excellence in 3D printing, and hope we'll have a number of printers, and we'll be commercializing many products. Thank you very much, sir, for your
thank you.
Informative presentations.
Good evening, Dr. Guru Prasad. Thank you for joining us. Thank you. Yeah.
Sir, now I would like to introduce Dr. Guru Prasad K. Rao, who is a speaker for the next session. So, Dr. Guru Prasad K. Rao is a mentor and director, Imaginarium India Private Limited. He is a technocrat with more than 30 years of experience, including product design and development. Previously, he has also worked at Crompton Greaves, Titan, Tanish at significant roles, and his specialty include 3D printing and its application in healthcare, corporate development, product development. With this brief introduction, I would like to welcome Dr. Guru Prasad K. Rao once again, and over to you, sir.
Yeah, just a word of before Dr. Guru Prasad. Guru Prasad sir, can you unmute yourself? Yeah, just it's fine. Thank you very much, sir. VC sir, we had an opportunity to visit Imaginarium facility at Mumbai. Myself and Dr. Mamta, we both happened to visit his facility. It is a state-of-the-art facility, and they are doing amazing job there. They are not just in medical devices, they are in automobile, they are in aircraft, They are into jewelry making, and some of the things were very confidential, where he said, I'm not going to take you there because they're working for a customer there. So, but he was so kind enough, almost for more than 2 hours, he took us to the entire facility tour. And one unique thing that I liked in that is the HP printer, where the machine itself prints its own part. That was a beauty. So thank you very much, sir, for all that. Over to you, sir.
Thank you, Professor Dr. Pramod, and thanks, Dr. Gaurav, for inviting me for this wonderful.
Good evening, Dr. Guru Prasad Rao.
Very good evening.
Very warm welcome to you. And thank you very much for mentoring our both Dr. Pramod and
No. It is no mentoring. It is a learning together. Actually, any session we can only say in this world we can only learn together, co-create, and I think that's what is going to happen. Today we are in a pandemic, which is taken us all for a ride, all of a sudden. And so we are, as a company, we have never shut our shop, and we have been doing a lot of, fighting implements for the COVID, So today my presentation would be on fundamentals of 3D printing, and then about what we do at the Imaginarium, and also what we have done for COVID, in order to, I think some people have to be muted. There is a, can I request the host to unmute some of them so that I can have a, okay. So what I'll do is, thanks a lot, JSS. And I think I have a long relationship with JSS because it is like my home ground, because I am from Bangalore and I have worked with JSS as a faculty at JSS ATE Bangalore. With Mrityunjaya, Latte, and I was recruited by Professor Dhananjaya. So there is a lot of respect and homecoming, feeling of homecoming. And whenever I meet Dr. Pramod or Dr. Shetty, it's always like that, feeling of coming to your home, So same feeling I have today, though I am sitting here in Mumbai and long distance. COVID, thanks to this, we are able to have this technological, connections by which you are able to, move ourselves, in visions. Well, I'll share my presentation now. I will share my presentation. Let me see if I can. Yes.
Yeah, it is visible, sir. It is visible.
So I think it just went quickly. This is the okay. It's a thing of shame that why we are still talking about 3D printing as a next big thing, because even after 30 years, this cartoon is for that, mocking at us. And we know the human development started with in the industrial and then soon the trains introduced by Ford and all, which brought in a lot of things, engineering, the electricity, the methodologies, wind tools, and then with power and all, there is no limit to the way we can actually this thing. Today we are into another big wave of revolution called 4.0 or cyber physical systems, wherein there will be everything will be controlled by the net and internet, and few people are required, autonomous robots, and there is a lot of ethical issues also here. Do we need to do empowerment of robots? So much they will take over us. Will the artificial intelligence nature of seeing all. So there is a strong ethical committee which is on the design of such systems. To make, that is another thing. Well, coming to the, the technology invention, thanks to Chuck Hull in the year 1983. You can see his humble setup, which is looking like a computer there, and CVT and something like a printer. That was the first printer. And you can see he's showing the first part which is printed, And it all started with a photopolymer, the monomer, which became polymer by taking a energy. It needed some energy to become a polymer. Then cross linkage happened, and that's how it became instantly a crystalline solid. This paved way for one technology. And because of patent regime, you have various technologies today. It is like 3D printing means is different to different people. It is not. It is SLA. Yes, it is 3D printing. SLS. It is 3D FDR. Yes. LOM is it is like a blind people things and bring us to the definition. How can we have a definition of 3D printing which will include all this? Pramod sir said how B is depositing. It is creating and also in my kitchen, mother prepares so many dishes like chakli and all, and jalebis, or it could be anything like that, sabudana chips, the frames like thing. All of them, they are very similar to additive manufacturing, additive way of building. And according to me, there is a small difference why we cannot call bees which will fabricate object layer by layer by digital input data. The digital input data, is going to seal it actually. So B doesn't give you digital input data. Mother doesn't give digital input data. That's where they're not 3D printing, And 3D printing is a subset of additive manufacturing. What is additive? Anything which you build by adding. Bricks, for example. You have bricks and you build buildings, and that is additive. The pearl which gets deposited layer by layer is additive. Nature, the timber is additive. Which will have annual rings and all that. So that way, in nature, it is full of additive only. There is no subtractive in nature. But I think human beings have brought in subtractive, and subtractive is not so efficient. Today, the technology is making deep inroads into jewelry. You have medical, FMCG packaging, the lifestyle, architecture, automotive, aerospace, electrical, electronics, white goods, plastics, and Bollywood, Hollywood, and gifting, and it goes on. List is big. And today, you see such things will be seen in the future. Industry needs large format printers which will work very fast. Somewhere they have to catch up with the conventional. Not really fully, but at least somewhere. I think we are getting there already. And today, each one of these technologies, they come with their own advantages, offerings. So we have a palette of things at Imaginarium, whatever you see here. Some more things have been added now. This is a word slide, I should say. So what we do at Imaginarium, as Professor Pramod highlighted before, projects under Rapid, where we work on aerospace, automotive, FMCG packaging, engineering, light and heavy, both automation, all those things. We work on life, which is for the patient-specific solutions that includes devices and implants and surgical guides, etc. We are into precious. We make pure gold ornaments, which are jewel, worthy. They're not imitation jewelry, but fine jewelry, and we are into solutions which will try to um, help industry adopt hardware and software for this technology. We have an academy which is going to share the whatever we have learned for easy adoption. And ventures is a corpus fund we have for the startups to enjoy creating in this allied space. And in medical, of course, everything will be used for end use. Medical is also like that. Medical, whatever we have is for the end user application only. And if we see, we have 5 different levels we can classify where 3D printing can contribute. I think this was also highlighted by VC sir before, and also by Professor Dr. Pramod. We have devices. In a way, they are arranged in the increasing order of risk. In the devices, the relatively risk is less, and anatomical model also risk is less. We have guides and fixtures where it will come in contact with the human tissue. So it has to be compatible, biocompatible and all. Those things, sterility is an important thing there. And then we have 4th level implants. Implants are going to replace some body parts. So it has to be not only biocompatible, but bioimplantable. So they have to be, accepted by the body. So there are various techniques by which we do the acceptability also, if it is not. And at the 4th level, you have tissue and organ printing. This is where we are actually actively observing, and we are part of the DIFAC committee on the fabrication of organs, and we just still yet to meet and give a final report. Then they will start looking at some programs which all of us will be involved to co-create. And moving forward, I think what brings 3D printing and medical bio together is the capability of the DICOM data being rendered as a volume, and so X-rays can be rendered, or MRI, CT scan, PET scan, echo, all of them can be actually volume rendered and volume exported, so that what you can render, you can also export and print them. In fact, it's possible to print organs for exploration. The patient-specific defective organs can be studied beforehand. So it's called pre-planning. So what you see here is a connection how digital model one side, 3D printed model other side, to our 2 branches, which will give us insights into our inside the body, which will help clinicians to take a better, decision as we go. So let me move quickly. So this is about devices. We are into devices. We are into anatomical models. This shows one of the slides from my research into congenital heart. So we in fact made soft congenital hearts, which can be dissected by a scalpel to actually know how is the morphology inside. So I will probably talk more about it in some other day, because today Dr. Shetty is already going to talk about it. And we also have done implants. Today, I think about 8 to 9 implants successfully implanted into the people. From pain, we are able to create smile because of the interventions. Technology is of no use if it cannot bring smile on somebody. So their life should be saved. Quality of life can be made better by technology. So I think that's where the medical thing is going. On tissue printing, of course, it's a long way to go. Today, it has become like the God is playing hide and seek. Whatever you can do on a petri dish, you can grow a tissue on a hydrogel, and you can have a scaffold, and you can grow those. But vascularization has been a great problem, because no, that's where somewhere, no, I cannot print the capillaries, fine capillaries of blood vessels to carry the conductive tissue, supplying the, the food and taking back the excreta back. That kind of system, that is the vascularization that has to happen, without which, the organ printing is incomplete. And that's where I think God is playing hide and seek, and God favors the prepared mind. So let us all be prepared and be ready to receive God's blessings to make the organs possible. It is like becoming a Brahma, in some sense. And COVID has brought in a lot of things. We have made a lot of quick this thing devices like face shield. You know, the corona is something nobody has seen it. So I was searching today for how it looks. How it may look in a microscopic thing. So you can see the animation of COVID. And this has triggered a lot of projects like the one what I show you. You see here the face shields. These are face shields. The mask is not done by us, but the shield is done by us. This is the drawing what we have. You can see initially it was 3D printed, and 3D printing, as you know, it's very lousy to make bulk. Then we shifted to laser cutting. Laser cutting also, there is some limit. It cannot match injection molding. So within 10 days, first day we did 3D printing. We finalized the design. Then we shifted to laser cutting. Laser cutting again was not very fast. Then we shifted to injection molding. So today we have already delivered more than 7 lakhs face masks. For government and very many organizations like police and the doctors and these people, we have given it free. Some NGOs are coming forward to buy it and then distribute. So that's where we have done all this. This is not for profit. And ventilators, Peter, was something which came in a big thing. So we had inquiries from Seven Hills Hospital, Hiranandani Hospital, SRCC, HS Reliance and all. And these are some of the designs we got from the clinicians and the technicians. And we could, because the whole world was closed, we were the guys who were open to do this. We got a special approval for this by BMC, Mumbai, and police. So our team were there, helping out, making these things. And people have actually tried it, so some of these are made by Pursa printers. So it's very important to keep the cost low. And we are also trying here. It's a kind of jugaad, it cannot be permanent, but because it is required so urgently on demand, we did it. And we also have done the Venturi valves, which are there to regulate the air, create a negative pressure for the airflow, and they were very successfully delivered to people. And surgical mask is something which used to create a different kind of pressure, and people wanted some adjustability. So some of these extension things were also made. Many of these are not our own designs. This is a open source things available floating all over the world. So most of it we have taken from there. This is oral care device where there is a request from a particular clinician group. They provided us this, and again this is also a open source. So there is no patent or anything here. And of course, how to open doors, how to manage with the things, with to break the chain. We have done many things which are in line with that. Aerosol box is also one such thing we made, and we tested it in a hospital. Before that, it was tested on one of my colleague. He got married on Sunday. There was a lockdown marriage for him. We all saw him on Zoom. I'm not putting his photo, but yes, there's a lot of fun making this. So I think on the whole, COVID has given us a new kind of energy. Uh, it has also told us, we can do it. Hum kisi se kam nahi. India can do it. We don't require anybody. India, with its very learned and large clinician groups, like we interact with JSs and many others, and we have a lot of academicians and the premier institutes like JSs, IITs, RECs. You have together we form a deadly cocktail for innovation. We have Ravi Shankar. He has been doing a lot of these, internal organs and all, which are going to give great insight. So such people together. I'm really thankful to Dr. Pramod Kumar for setting up this small interest group. Which has helped me immensely to learn, interact with great minds, and it's a great co-learning opportunity. And we really thank you for that, sir. And I think with this, I come to the end of the presentation. And as you see, these are some of the verticals we have. And I would like to take the questions after the session. I'll stand by. Thank you, sir.
Thank you, sir.
Thank you very much, sir. And first of all, I should thank you for accepting our invitation without anything. The first thing when we asked, it was without any hesitation, you accept our invitation. And giving a brief introduction about 3D printing and sharing your success stories at Imaginarium. So, and you are supporting during this COVID-19 pandemic with your products also. That's a great thing, sir. And during this pandemic, on behalf of JSS Academy of Higher Education and Research, I profusely thank you for your wonderful presentations.
Thanks.
So I'll be starting with the third session. So I would like to introduce Dr. Ravi Shankar SN. He is the Managing Director, Create Additive Labs, Bangalore. He is an accomplished design expert. He has worked with clients both in India as well as globally. And he is the nominated member of the Innovation Council of leading medical university. And he has worked with 3 big blues, that is Hewlett Packard, Siemens, and IBM. He has a strong international experience. He is very proficient in German language, and his specialties include health technology, medical trainers, simulators, emergency care trainers, 3D bioprinting, and bioink formulation. With this introduction, I would like to welcome Dr. Ravi Shankar. Over to you, sir.
Thank you, Dr. Gaurav. It was a very kind introduction, and I will I also thank the panel for having me along. I will share my screen. Just tell me when the screen becomes visible.
Yes, sir.
Yeah, can you make the screen big, sir?
Yeah.
Yeah.
Is it okay?
Yes,
Yeah.
sir. Yes, sir.
Okay. I have about 15 minutes, so I will try and pace myself so that the initial introduction is a little lighter and we get to the meat of the topic much earlier. So I'm going to talk about serving patients and doctors during COVID-19 with design innovations. Many people think just of patients, but then, doctors also have a need. And that's what we discovered. If you take care of the doctor, the nurse, and the paramedic, then the patient is taken care of. So what you see at the bottom is an image, a 3D printed image, which represents in 3D form how the coronavirus would look like internally. That's just to set the focus. Amongst the things I'm going to present where we have been involved in, it shall include mobile devices which have found applications in this pandemic as declared by the World Health Organization, respiratory assisted devices, and examination instruments. Some things are a little confidential, hence I may not be able to share details. However, they are valuable in the current situation, so it's probably worthwhile just mentioning them. I'm also going to talk about a third element, which is training and reinforcing confidence in medical workers. This also is something which is important. When we get to that slide, you will see why that's important as well. Okay, about myself, my name is Ravi Shankar. I have over 3 decades experience in applying innovative technologies to clients. I think that's where my core experience is in. I head research and innovation at Create Labs, and I'm also the lead application consultant for medical trainers and simulators. I've been working in healthcare technology for quite some time. I lead Create Labs, which is a design and innovation company. I've been a co-principal investigator in some research projects done collaboratively with academic institutions. And I'm also the lead inventor for a self-actuating, customizable, expandable upper limb prosthetic device. And currently I'm setting up a Jeevaraksha accredited training academy for COVID-linked emergency nursing care and basic life support. So this is some of the things I've been involved in and where I come from. As a company, our portfolio includes modeling services, biotissue printing, and medical simulators. This tells you the breadth we are involved in. So naturally the depth will be vary in some areas. Now coming directly to what is of interest to you in this webinar, I think serving patients through the hospital is the first string I wanted to take. When we look at this, what you see some examples here is robots, self-navigating robots or remotely controlled robots doing disinfection. Now, if you really look in India also considerable efforts have been made to prototype and make available for testing. This is the first image which you see, which has this Bisleri bottle there. This is one of the devices we are involved in. So this device is remotely controlled and was meant to provide food packets, water, and medical supplies which are required for patients to take frequently, specifically in isolation wards where people don't want to go in and you don't want people to come out. So these kinds of devices, which was actually developed by a DRDO lab, and we had a chance to bring in some of the 3D printed elements, was meant to provide a safe mechanism for serving patients who are already isolated. However, needless to say, it takes 2 hands to make a clap. I'm not sure if enough hospitals implemented this and reduce the risk of their own persons who are working in hospitals. So this concept can also be used for spraying disinfectants using UV-based sterilization mechanisms where you want to sterilize an area, or applications can vary. And this is one of the areas where we managed to do some small work by helping this lab to rapidly prototype a remotely piloted vehicle. Then the most important aspect where 3D printing has really come to center stage, and the world today knows that 3D printing is an important enabler in the COVID thing. This all started when FDA, which is the Food and Drug Administration, issued an advisory. See, normally what happens when you use class 2 devices, there's a lot of approval process, sometimes can take more than a year, but FDA was very quick, was to provide an enforcement policy for ventilators and accessories during this COVID crisis or pandemic. And this guidance was something which could immediately be applied by various institutions. So amongst this, we had a chance to work in 2 areas. One was the mechanical ventilator, and the third was a positive pressure breathing device with intermittent flow. Now, these 2 devices were something where we had a chance to work, but we were helped by the fact that the clinicians knew how a ventilator works. And there was also an FDA guidance in terms of how these devices should function and what are the operational parameters. So we were supported by that, and we did some work in this area. Now, just for some of you to get a grasp, when you look at ventilators and masks, typically what a patient has on his face is most of the time a background mask if he's in acute distress. And there, some of the elements which can be 3D printed include the expiratory valve, where the carbon dioxide goes out. So that's also called the scavenger valve. Then when you come down to the air inlet and pressure release valves, that's the point where multitasking can be done by making an adapter to one ventilator and splitting it into 7 or 8 or 6 devices feeding different patients. So if you really look, what are the different applications of a ventilator mask? We could easily come across 6 such applications. There are probably more. Scavenger valve is one application where we have done some work. Splitters, Dr. Guru Prasad talked as well, where you can also include a factor of variable flow. See, everyone that does not face the same element of distress when they are in ICU. Some of them probably need less volume of oxygen, others need more. So variability in flow when you put in a splitter will be a very effective mechanism. Then the third thing where we had a chance to work, I'll share some details on this, is a mechanical powered ventilator. See, hospitals invest, I don't know, 20 lakhs, 30 lakhs and have ventilators in their ICUs and operation theaters. But if you think of a day when you have to serve 100 patients concurrently with ventilation, what you have in a hospital is not going to be enough. So that is when thinking of a mechanical powered ventilators, which is very cheap and is mobile. You can move it to your tertiary care centers and doesn't need power, because when you leave the big cities, electricity may also not be available. What would you do with a ventilator at that point of time? So for a country like India, I would say a revolutionary idea would be to produce adequate number of mechanical powered ventilators, which a family member or an assistant to a patient could also power. And this probably wouldn't even cost a 5-digit number like 10,000 or 12,000. It would cost substantially lower. So I think that there's a very good idea here in making mechanically powered ventilators, and it doesn't take long to make them as well. We don't know when corona is going to peak and when the acute respiratory distress is going to peak, but there's still probably the small window of time where more and more mechanical power ventilators could be made and the logistics made to put them out into different places. Because it's sad when a patient dies in a tier 3 town because there's no ventilator, or he dies on the road, the photos of which we are seeing, where he's trying to reach a city and you find them dying on the roads. I think these are avoidables, and I would very much like to see as a benefit out of such webinars, if someone picks up the idea and gets to making hundreds or thousands of mechanical power ventilators. This is something where we got involved. I'll show you some details. Then of course there's the CPAP patient mask for high risk patients. See, today just a N95 mask, the N95 mask costs something. Then a surgical mask costs even more. People spend 4,000, 5,000 rupees just for a mask which doesn't even solve the problem. So therefore, a non-humidifying mask for surgical usage is also, I think, a brilliant idea. Then, of course, in procedures like ENT and dental, you have aerosol preventive masks. This is a 6th application. So what Dr. Pramod has on his hands is, and I would say dozens of ideas, but at least half a dozen of them in the area of just ventilators and breathing, which have very critical applications in today's context. So this is a Japanese university-based company which has come up with an idea. It is all in public domain. Like Dr. Guru Prasad said, the world has been quick to collaborate in this COVID era. So they actually started making this mask to work in space. And then when the COVID-related pandemic started, they explored the possibility of quickly downscaling this and making it usable as a mechanical ventilator. So the complete design, the way a mechanical ventilator could be made, is now in public domain, as also guidance on how to adjust the flow where you need some regulation. We tried working with this company, but in the end, the company had some concerns of moving out of Japan into India in such short notice. And hospitals were also not quick in saying, yes, we would like to sponsor 100 and let's get it to the most required places. So this is still, we made some parts. I can show you this. This is also in my hand. This is one of the mechanical compression levers which we made. And this is a scavenger valve which we made in the course of proving this prototype. So I think for a country like India, mechanical ventilators, once they become known and accepted, probably will be there in every small taluk or district headquarters. And we were really glad to have been exposed to this concept of mechanical ventilator, which might not cost even as much as 30,000 rupees, 10,000 rupees, substantially lesser than that actually. Then, of course, there is semi-automatic ventilators. We did not get to make a semi-automatic ventilator or parts for a semi-automatic ventilator, but we got an opportunity to design and write out the clinical requirements for a semi-automatic ventilator. This is where clinical know-how, a handshake with a clinical company, and engineers like us who can convert that into a performing device comes into picture. So we could clearly write out in terms of what needs to be done, what's the typical operating parameters of a healthy patient, and what's seen as not being compliant in terms of respiratory status, and the typical terms you would see on a ventilator in a hospital or an ICU, and how we have to convert that back into controls. So at least we got a chance to understand this and convert that into switches and controls in a system design. So this is one example of the design and requirement validation we did for a semi-automatic ventilator. Then again, there are some things, I just borrowed this image. There's something called PEEP, which becomes extremely important. So even when you make a ventilator mechanical or semi-automatic, having pressurized air at the right volume to create PEEP, or where the aerobally expands enough to allow air, oxygen to come in contact with and participate in the diffusion process is very important. And this is where I think a lot of people are going to face distress in the Corona-19 pandemic. So it's important for us to understand all the different normal parameters, where you need controls and where you could possibly simplify. I just thought I'll share this with you. Then another area where nothing has happened, but probably it's possible, is integrating a eye protective device with the mask. Especially if you can imagine people doing medical examinations. Eye is also a potential area of getting exposed to COVID virus or any other pathogen for that matter. So it's quite possible to imagine a mask with a HEPA filter, if you like, especially if you know if the patient's already, affected by a serious pathogen, or if it's not, then you don't need a HEPA filter, you could go with a normal filter. And integrating a spectacle or shield with a filter is probably something which you must consider when patients face moderate to high risk and a doctor or a medical worker needs to handle that. So this is another area where people have appreciated the utility, but probably it still needs to get into the hands of medical workers. What I want to bring to the notice of this forum in this webinar is a lot of challenges have happened the world over, which has led to a lot of devices being made. So maybe, as a fallout of this webinar, if the SIG could anchor one or two such challenges and try and get these devices to doctors like Dr. Shyam Shetty and maybe some of your tertiary clinics in Suttur and other places, whether it's making a ventilator or whether it's making a protective device. All of these are ideas. This Code Life, which you see, there's also one from MIT, where they have given the complete blueprint of everything which can be done. And needless to say, about 30% of them are 3D printable. So there's considerable value in this. And Dr. Guru Prasad talked about this, sharing ventilators. A luxury in a city private hospital in Bengaluru is maybe they don't share a ventilator. A patient who doesn't need a full volume of ventilated air, oxygen, still uses one. But I wish there was a rule where every hospital handling COVID patients had to have a few dozen splitters. Because now you will find, you're starting to read that patients don't have ICU beds, don't have ventilator availability. Splitters are a very easy option, and I think it should become the norm. Hospitals should have this. So that's one thing. Then if you look at the oxygen volume in any air, I think it clearly points out that you normally take in about 20% oxygen is what is there in normal air, and that's what everyone is used to. So splitting is not going to hurt any patient, and oxygen supply can be split between 8 to 10 patients, assuming a normal median of distress. And the third point I wanted to bring is medical workers need a lot of support. This is something we fail to recognize, whether it is ASHA workers, whether it is paramedics in an ambulance, or whether it is nurses in a hospital and supporting staff who clean, and the doctor patient, infection, and so I think these are some of the measures. In combination of some of this should become a standard new protocol for handling let's say ICUs and trauma and other places where trauma, for example, you don't know what are the probability of the trauma patient who's coming from an accident being also corona infected. You will never know. So I'm sure there are enough applications where these should be used. This is another example where we were involved in. CPAP mask, which is continuous positive air pressure mask for ICU patients. So here a hospital wanted us to build an adapter to a commercial off-the-shelf mask. This mask was extremely good in terms of insulation. That means it was separating the flow of inhaled and exhaled air. And here we, as a first output, we produced a simplified adapter with a common outlet for exhaled air. That means at the outlet, the incoming air and outgoing air would mix, but it was a very low cost device, and they could consider considerable number of such adapters. But when it comes to a patient, which is what you see in yellow, which might be in a OT, or you have a need to separate exhaled and inhaled air for a very critical reason, that exhaled air is high on humidity and tends to fog the glass in front of your eye. A lot of doctors are struggling to be in OT because the high humidity air which they exhale tends to fog the glass. They might be wearing spectacles, or they may be just having the glass protective device on front. So that's a big problem. So a mask like this separate out the exhaled air and make sure it does not mix with the incoming air. And as a result, even if they work 8 hours in an OT or 6 hours doing a procedure, they have clear vision from this mask. So we built the adapters for this, and this was tested. You can see the figure on top with a a device where he's measuring the flow from the minimum sustainable volume to the maximum sustainable volume. And I think doing some of this work was satisfactory. You also see the filters here, the HEPA filters, which is the one with the blue sticker ribbon running around that. So I think having a chance to work on this gave us intricacies into the clinical parameters and what surgeons look for. The last area where we have now started working in is, like I said, there is near panic. In fact, when we went to medical college, the management was trying to tell doctors not to resign and not to walk out, or avoidance of duty. These kinds of problems come from two issues, I think. I mean, in a way, you cannot blame doctors here because there's definitely a probability that they'll get contaminated. So what is being done to reduce that risk of getting contaminated to the minimum? I think that's the question, that's the answer, which all these medical workers, if they are made aware of, probably will have a more committed and a more energized working team. So we have been involved with Jeevraksha, which is accredited, university affiliated emergency care training and skill provider. They work with hospitals and other places. So here the offering which we are working on is to train medical workers, right from residents, doctors, nurses, paramedics. Sometimes it's the residents who take most of the brunt. So working with them and training them on how to handle a COVID-19 compromised patient or suspect. See, if this training is imparted and they are practicing on that, the ease with which they can then go and work in the hospital enhances by a factor of 2 or 5x. So this is something which we have just now got started, and this will equip these people with skills, protocols, and practice so that they are more confident and do not have the fear in their mind when they're supposed to concentrate on patients and the well-being of the patients. So I would like to end by saying that handling COVID patients should not be a misery for doctors, nurses, and paramedics, but something they should handle with confidence and effectiveness. So we believe some of this trend, which will go on for months now because of this pandemic, can outlast the year. We hope to equip many hospitals in this regard. Thank you. I hope I have not exceeded my time, and thank you for your patience.
Thank you very much,
Yeah.
sir. Your design innovations, and prototyping of equipments, especially during this COVID-19 equipment, especially supporting with the mechanically powered ventilators, semi-automatic ventilators, and also supporting the doctors, nurses, and all the paramedics during this COVID-19 pandemic. And by supporting with the personal protective equipments and giving training to the emergency or medical workers. I thank on behalf of JSS Academy of Higher Education and Research, I thank you for giving a very excellent presentation, sir. Thank you very much, sir.
Yes, good evening, sir. We have Dr. P.A. Kushalappa, Director Academics, has also joined us. Thank you very much, sir, for being here with us and guiding all the SIJs of JSS Academy of Higher Education and Research, and giving us the new directions for all these things. And just as a word of appreciation, all these SIJ panelists have been supportive in submitting a number of projects on behalf of JSS AHER for various funding agencies. We went till the last step and we could not really make it. Nevertheless, it was a wonderful experience that we shared. Night through, we prepared the presentation, and it was really great learning for all of us. Thank you, Ravi Shankar, for all the support that you have been with us for taking up this project. Thank you very much. And it was a wonderful presentation. You are always been champion in driving the message straight. Thank you. It was wonderful to hear you again once more. Thank you.
Thank you, sir. So we'll be starting with the fourth session, sir. And now I would like to introduce the speaker that is for the fourth session, Dr. Shyam Prasad Shetty. He is an associate professor and head of the department in cardiothoracic and vascular surgery. And he is one of the highly experienced cardiothoracic and vascular surgeon in Mysuru. He is also has a completed senior management program from IIM recently, and along with his existing fellowship and recognitions from the Royal College of Surgeons of England and Edinburgh. His interest in research has driven his passion towards 3D printing in healthcare. With this brief note, I would like to invite Dr. Shyam Prasad Shetty for the session, sir. Over to you, sir.
Can you please unmute your mic, Doctor?
Yes, sir.
Hello, good evening. First of all, let me thank all the the special interest group of 3D printing for inviting me. Thank you for the talk by Dr. Guru Prasad and Dr. Ravi Shankar. And we know such a small splitter in a ventilator had made such a big difference. All these years, we were not aware of the splitter, or we were not making use of the splitters. And how necessity became an invention, and how we could ventilate 2 or 3 three patients by using a splitter. And you all know now how the splinters can be easily manufactured locally. Now, my topic for today will be on 3D in cardiac surgery, on heart surgery as such. Now, let me go to the topic straight away. 3D printing in cardiac surgery has been going on for quite a while. We've been using physical models to study the structure of the heart as such. So 3D printing consists in the conversion of digital images into 3D physical models. We have already mentioned is like how DICOM, which will give you a volume and a 3D picture, can be converted into a physical model. And this physical model gives us an accurate picture as to exactly how the structure of the heart looks like. And this is going to help us during teaching, during a surgical planning, or developing implantable device, and so on. The application of 3D printing in heart is in various areas like congenital heart disease, coronary artery disease, and in surgical and catheter-based structural diseases. 3D printing is utilized for several purposes, such as in teaching, in planning a surgery, development of a novel or a personalized implantable devices, and also for creating scaffold for tissue engineering and artificial functional tissue regeneration. This is what they do. They studied the CT or the MRI of the heart, preferably a CT, and you can reconstruct the heart and the structures around the heart using 3D printing. And this is going to give us a good understanding about the structure of the heart. You can also see the inside of the heart. Even before you open up the heart, you have a good understanding as to what is going on inside the heart, the relation between the different structures within the heart. What is the relation between the right atrium and the aorta, relation between the aorta and the pulmonary arteries, and all the different structures. If there is a disease or a defect, we can actually identify the exact location of the disease and the defect, and we can plan the surgery accordingly. So we are well prepared even before we open up the heart. And if any changes have to be done intraoperatively, this can be identified pre-operatively itself. So a 3D printed heart or a model of the 3D printed heart gives you a very good understanding and a visualization. You can feel it. If it is a soft model, you can dissect it even before the operation and know exactly where the structures are going to be and the extent of the defect of the structure, and you can plan it well in advance. Now, the 3D printing also is being used in vascular surgery, like thoracic vascular surgery. For example, an aortic work. If you see, there is a coarctation of the aorta here, the coarctation, the position of the coarctation, the extent of the coarctation, and is there any associated congenital anomalies can be actually visualized even before the surgery, and we can plan the surgery well in advance. Intracoronary stents. You all have heard about stents implanted within the coronary arteries. We can actually bioprint titanic stent which can be implanted exactly of the same size. The future is going to be that even the coronary stents at the moment, intracoronary stents are all being bought off the shelf, but in the future, intracoronary stents will be individualized, it will be personalized. That means if you know there is a vessel of 2 millimeter diameter of a length of 4 centimeters, we can individualize or personalize the coronary shunt for that particular patient. Heart valves can be printed, so we can study the CT scan or the MRI, and we can print the heart valves and study the anatomy of the heart valves well in advance. Heart valves can be single leaflet, bi-leaflet, or triple leaflet. Normally they are by triple leaflets, but sometimes if you're born with a defective in the heart valves can be a bi-leaflet or very rarely a unileaflet valve. Now, once we know the size and the nature and the structure of the valve, we can plan our surgery well in advance. If we can actually make a pericardial valve or use a pig valve, prepare it well in advance in table so that we don't waste much time on a heart-lung machine or waste too much of time intraoperatively. This can be done on the bench and then implanted on inside the heart. Here you're seeing an aortic valve which has been placed inside the aorta or in the position of the aortic valve. Well, if you have a 3D modeled heart, we can actually have a very good understanding of the aortic valve, where exactly it can be placed. Now, this can be manufactured or 3D printed pre-operatively and placed within the aorta. Aortic models. If you look at the abdominal aorta with all the branches coming off the abdominal aorta, we can, if we have a model of a 3D printed model of the aorta, we can actually manufacture an endovascular graft well in advance, which actually really fits it, because endovascular grafts cannot be bought off the shelf. It has to be individualized, it has to be personalized, and these things takes time. For example, once we take all the measurements of the CT measurements of the aorta and we send it to the manufacturer, it usually takes 2 to 3 weeks for the graft to be available. But with the help of 3D printing, we'll be able to get the precise size. Because, for example, even if there is a 1 or a 2 millimeter gap between the wall of the aorta and the endovascular graft, there is going to be a leak around the graft, which is not wanted. So if you have a 3D printer, we can exactly print the endovascular graft to the patient's need. This is the aortic model of a 3D of a ascending aorta, arch of aorta, descending aorta, common iliac vessels, and the femoral vessels. Where once we have a model, we can actually study and we can actually train ourselves as to how we can say, for example, you want to put a stent in the renal arteries, or you want to put an endovascular graft. This kind of 3D models will help us to train pre-operatively and make ourselves comfortable and make our life easy, because we already tried it off table with a 3D model. This is how an endovascular prosthesis is put for coarctation of the aorta. You can see a 3D printed stent has been inserted into a coarctation of aorta to keep it open. Endovascular grafts, I have already spoken about, can be printed and individualized. TAVR or transcatheter aortic valve replacements are taking over the world in a big way. everybody is doing a TAVR, but still there are problems with the sizing of the TAVR, sizing of the aortic valves, the mitral valves using TAVR. But 3D, if you have a 3D model, you can actually personalize the TAVR, the aortic valve, for the individual patient itself, and the results of the TAVR will be better. Paraprosthetic leaking or leaking around the aortic valve is going to be minimized, because one of the problems we have is leak around the thing. So we can personalize these aortic valves for every patient. 3D printing, you have already seen Dr. Guru Prasad talking about 3D printed titanic implants into the brain. Same implants can be used for the rib cage. For example, you have missing ribs or the sternum, you can implant, you can have a 3D printed titanic rib cage. 3D printed tracheal grafts and stents are being commonly used now. You can individualize tracheal stent for a particular patient with the help of CT thorax, and this has been widely used. Repair of the thoracic wall, we can use a silicon or a titanium ribs which can reconstruct defect in the thoracic wall. This is very similar to what we saw in the previous slide. 3D reconstruction or a 3D printing of mediastinal structures. For example, if you see here, the green one is a lung cancer that is sitting very close to the pulmonary arteries and the pulmonary veins. Once we have a 3D picture model, we can have a better idea of the extent of the cancer, extent of the involvement of the cancer into the pulmonary arteries and the pulmonary veins, and we can plan our resection accordingly. And this will give a very good picture for the surgeon on table as to how he can approach the cancer, what all the structures are being associated with the cancer, so that we can give a complete resection of the cancer. Again, another picture of a 3D in lung cancer, how beautifully a 3D will give us the location of the tumor and the neighboring structures. Cardiovascular applications of 3D printer, patient-specific models. The advantage of a 3D printer is it's always patient-specific models. You can't buy these things off the counter. Can be created for a number of different applications, including creation of anatomic teaching tools, development of a functional model to investigate intracardiac flow, creation of deformable blended material models for complex procedural planning, and increasingly patient-specific models are being deployed to assist efforts to create or refine intracardiac devices, because a lot of intracardiac devices have come up. You have the Mitra clip now, you have the TAVR, you have the ASD device, you have the VSD device, and so on. And these devices are taking over cardiac surgery. Cardiologists are able to put this device, and if you can put this device, you can avoid an open heart surgery. 3D printing helps us to image, plan, carry out cardiovascular patient-specific interventions. Cardiac applications in congenital heart disease, coronary artery disease, surgical and catheter-based structural disease. So there is a whole new specialty called structural heart disease, where all these things are going to come in effectively. So some of the applications, I just read it out, is aortic arch pseudoaneurysm, creation of custom-made occluders for aortic pseudoaneurysm. You can make a device. If the patient has got a left ventricular aneurysm or a RV tumor, a 3D model facilitated a surgical resection. You can the 3D model will facilitate a resection, 3D right ventricular tumor, also severe aortic stenosis, evaluation aortic stenosis models under patient-specific flow condition, hypertrophic cardiomyopathy, septal myectomy guidance and procedural practice. If the patient has a HOCM or a patient has got hypertrophic cardiomyopathy, you can do a septal myectomy with a guidance of a 3D printed model. CBRMR, mitral valve model used for selection of repair devices. Now, mitral regurgitation is a very complex topic because it is not only the mitral valve, it's the chordae, the papillary muscle, the left ventricle, all form a unit. So it's a very complex surgery. And if you have a device, if you have a 3D model, we'll be able to plan our repair of mitral regurgitations well. ASD and VSD are very common. Pre-procedural planning for transcatheter occlusion of ASD. There are just a few of them I have mentioned. 3D printing can be used as a teaching tool. An early application of 3D print modeling was to create models for anatomic teaching and demonstration. Like the plastic heart, most healthcare professionals, 3D printed model can rapidly convey a complex anatomic arrangement, but has added value of also depicting patient-specific anatomic pathology. This is how 3D printed cardiac models have been done. The teaching models, you can 3D printer, multicolored transparent models. You can have a transparent model and you can see exactly what is happening inside the heart. Different colors given to different structures will also give us a better understanding of the model. This is a 3D printed multi-layered left heart model, and mitral annular calcifications can beautifully be seen and appreciated in a 3D model. Functional flow models. Patient-specific 3D models of aortic valve dysfunction can be readily created by combining the technologies of high spatial resolution CT, CD software, and multi-material 3D printing. Once we have this HRCT and CAD software, multi-material 3D printing, we'll be able to understand the functional flow models of the aortic valves. Functional flow models will give you exactly the flow of the flow within the heart and the aortic valve. Visualization, flow, and interventional models, which will give you a good visualization, which will tell us the flow, and also it will tell us how we can intervene by using this model. Procedural planning. Before you plan a procedure, a surgical procedure, we can plan it off the table itself. Congenital cardiovascular diseases are often associated with complex and unique geometry that can be very difficult or fully appreciate from 2D, CT, MRI, or echocardiographic images. As such, 3D printed modeling may play a key role to provide a more comprehensive understanding and functional evaluation. This is how you can plan. Looking at the defect of the ASD of the VSD, we can plan pre-operatively. And also pre-procedural planning of catheter-based closure. For example, you want to put an ASD device. Now, this is the right atrium, this is the left atrium, and there is a hole in between this. So you can implant an ASD device. You can see the hole here, and they put an ASD device. So a 3D printing model will help you to plan a catheter-based closure of the device. Again, another picture of how a 3D printed model is going to help us during the surgery or during a closed procedure. Here you can see an endovascular stent has been put, the 3D printed endovascular stent has been put, and it is going to help us in a transcatheter, a TAVR, or a transcatheter aortic implantation. The other topic I want to mention is bioprinting. Bioprinting of tissues construct largely depends on material properties as it needs to be fabricated in an aqueous environment while encapsulating living cells. The decellularized extracellular matrix bioinks proved to be a potential option for functional tissue development in vivo and as an alternative to chemically cross-linked bioinks. However, certain limitations such as printability and limited mechanical strength need to be addressed for enhancing their widespread application. So there are limitations. This is a picture of a bioprinter. Bioprinting a cardiac valve. Bioprinting is an emerging technique that can produce biological products containing matrix and cells together or separately with morphological, structural, and mechanical diversity. This advance increases the possibility of fabricating the structure of a heart valve in vivo and using it as a functional tissue construct for implantation. So we can individualize these bioprinted cardiac valves. An autologous human heart tissue valve has been printed using a 3D printer. A bioprinted cardiac patch composed of cardiac-specific extracellular matrix and progenitor cells for heart repair. You can repair an infarcted heart by using a bioprinted cardiac patch. A 3D bioprinted cardiac patch are printed with bioink. They are composed of decellularized cardiac extracellular matrix hydrogel, human cardiac progenitor cell, and gelatin methacrylate. This is one of the protein patch that was used to repair the heart. You can see here in vivo printing helps cardiac function, it protects the heart, it improves the angiogenesis, decreases the fibrosis, and decreases the cardiac remodeling. An injured heart, you're using a patch which is being printed by bioprinting. These are going to minimize the scar, and this is going to increase the cardiac function. Artificial blood vessels have been created. We don't know how functional they are. They're all in the very primitive stages, but I'm sure in time, all these bioprinted blood vessels will be functional. This is one of the 3D printed blood vessel. It has got all the 3 layers, the tunica, intima, media, and adventitia of the blood vessels present. And I already mentioned these are replacement heart valves already being used in vivo. This is a 3D printed trachea. So there are so many structures that can be 3D printed. I'm talking only about heart, blood vessels, and the thorax. 3D printed heart tissue, a functional 3D printed heart tissue, has been printed in Tel Aviv, but we have to wait and see how this can be used clinically in the future. What we are hoping for in the future, one day, we have an organ bioprinter. We can just print any organ we want using this organ printer. I'm sure it will happen in time. The future directions will be with the applications of congenital heart disease, coronary artery disease, and in-surgical catheter-based structural disease. 3D printing is a new tool that is challenging as to how we can image, plan, and carry out cardiovascular intervention. Patient-specific 3D models may directly impact our ability to select appropriate patients for structural heart therapy, anticipate procedural complication, and potentially revise and improve the flood of intracardiac devices which are rapidly becoming available for therapeutic use. The progress must continue towards the development of implantable 3D printed patient-specific cardiac prostheses. This is the future. Like the 3D printed titanium devices now used for maxillofacial and other orthopedic repair, procedures, the near-term future for cardiac 3D printing may include custom manufacturing of repair devices, conduits, and occluders. This notion of personalized 3D printed cardiovascular process is not here today, but is now clearly visible on the horizon. Thank you.
Thank you very much, sir. Sir, am I audible, sir?
Yes, I can hear you.
Yes, sir. Sir, thank you very much. And it was a great learning experience for me. It was a first time experience learning about all this cardiac models, and especially that 3D printing can be used in teaching as well as in many vascular surgeries, especially in the heart models. It was a great learning experience for me, sir. It was a very informative session. On behalf of JSS Academy of Higher Education and Research, I thank you for a wonderful presentation, sir.
Thank you, Gaurav. Thank you to the SIG group, and thank you to all the speakers.
Ramo sir, would you like to add some? Sir, can you unmute it, sir? Can you unmute it?
Thank you. Thank you, Gaurav. It was, in fact, the idea of Dr. Shyam Prasad Shetty to have the webinar of this kind. Thank you very much, Doctor, for all this initiation. And that was a wonderful idea where we could connect in spite of all this COVID lockdown. And say it is when you speak, it is from the practical experience that you speak. So where application, whatever Dr. Guru Prasad or Dr. Ravi Shankar is going to make, the application finally ends up in your say laboratory or maybe in the hospital setup. I think it makes a lot of sense for you having given us all those inputs and for planning and things like that. And even Dr. Shyam Prasad Shetty was also there in number of the project proposals, and he has been constantly supporting us for all the various initiatives. So thank you, Doctor, for all that. And before we take up the question and answers, if it is okay, I would like to request, I have some submissions for you here, that as the panelists and other members of SIG of 3D printing, what I would request is, can we come out with one beautiful article of what was the 3D printing experience during COVID pandemic, where Gaurav would anchor all the different speakers, and you can share your experience and fine tune that article part. Maybe we can publish it in one of either the daily newspaper or maybe even in the leading journals also we can put, because all of you are great personalities in the respective field. That is one idea. Then since I have committed, put a commitment for myself saying that we should be establishing Center of Excellence of 3D printing in healthcare in JSS AHER by 2022, I need to have a clear-cut plan for myself ahead. So as we have seen our experience with DST SERB, when we went for the project proposal there, they asked for the prior experience. So I think this is also a platform where we can start with, say, for 1 year, maybe 4 or 5 projects, which can take up in a small way, and have the prior experience with us and go with that. So project proposals and publications, which will certainly give a lot of strength and confidence for us to go for any funding agencies for asking. And with Ravi Shankar, we can always work very closely with IAC Bangalore, where he is already connecting us with Kaushik Chatterjee, who has also got the Center of Excellence and things like that. I think it is possible to go ahead with that way. Yeah, over to Gaurav. You can take up, and then
Sir,
Dr. Kushalappa sir would.
Sir, we'll be taking about around 3 to 4 questions for the question and answer panel, sir.
Is that okay, sir?
Is that okay? Or?
Yeah.
Sir, the first question is for Dr. Ravi Shankar or Dr. Guru Prasad. How economical will be 3D printing in healthcare?
Well, it depends on where exactly it's applied. You know, so it is something like this. If I were to, print a ring, ring like this, in metal, it'll cost me 60,000 rupees. While if I made it, by any other conventional way, it is only 6,000 rupees, 7,000 rupees. So this is not a right application. But if I say we are going to save life, and then if you're charging somebody 60,000, then it doesn't really. So it all depends on not working on the weakness of 3D printing, but strengths of 3D printing. Today, we have such wonderful material thanks to the greater research efforts going on in this area. The biomaterial, bioabsorbable. For example, Dr. Shyam Prasad Shetty mentioned about the stents which can go, in the aortic interior to increase the, to make way for the flow, and those things will be left as it is. They can be absorbed. Such material are available, and I'm very glad to say that the material are also becoming cheaper because of the increased competition, increased efforts, technology also becoming mainstream with patents expiring. I think it is a wonderful time, a great alternative, and you can have a designer treatments, with this technology. So I don't think price is anyway going to come, because we are all unique people. The anthropometric dimensions of each person is different. So the matching happens perfect. Individualization, as Dr. Shetty said, from mass customization to individualization happens, and that is the best fit one can think of. And I think with this technology, it is possible. And I don't think the price is going to be a big problem. Hope I have answered this question.
Yes, sir, definitely, sir. Sir, and another question is there is a gap between clinical experience and manufacturing knowledge?
I don't think these two are something manufacturers can tell, but I think there is a co-creation that is important.
Yes, sir. Yes, sir.
So when I was interacting with Madras Medical Mission, where I was going for the knowledge of heart morphology study. Also, I was interacting with Dr. Smriti Ranjan Mohanty of Kokila Ben, where he is working on congenital heart diseases. We did almost 21 different live cases, on heart surgery. And in many cases, the interventions gave them a decision-making skill. And also, when the procedure is going on, if the industry people, the people who are designing and providing such service, it helps to empathize, with each other. The clinician showing his difficulty in the, so-called in Gamba, and industry is able to appreciate the need, the context. So they can teach each other, and then there could be a better solution that is possible because of learning, better understanding. It will help actually. So that's my take on it.
Gaurav, can you hear me?
Yes, sir. Yes, sir.
Yeah. See,
Yeah,
what is important is the industry and the clinicians. We have to work very closely. Unless we collaborate and co-create, this is not going to happen. There is a lot of things we can do together, but what is happening is we are still, the research is still lacking in this part of the world. And for research, somebody has to fund it. And if we both are going to benefit, we will work very closely. And there is a lot we can do, particularly the field of 3D printing and healthcare is, is enormous. There is a lot we can do if we work closely. Thank you.
Definitely, sir. And one more question, sir. In case there are no scans available, what are your design inputs?
I'll take that. I think when it comes to patient-specific models, you cannot do without a patient scan. So that's quite clear. However, if it is for anatomical studies, most design houses would have curated their own 3D models and even presented them and sectioned them in a way that classrooms professors can use it very effectively. So I would say that for educational models, you can curate from existing 3D models and even present them in a way that a specific point of view is well explained to the students. But patient-specific scans, you have to have scans.
Okay, sir. Okay, sir. And one more question is, does bioink preparation depend on the cell type, sir?
Yes, very much. I will take that. There's 4 or 5 families of bioinks. Some of them are gelatin based and some of them are based on other alginate based and so on. So based on the affinity and ability to support cells without them dying, you would choose the family of bioinks based on the cells you're going to use. So that way I would say that there are about 4 or 5 families of bioinks, and the choice of bioink is driven by the kind of cellular material you're going to use in bioprinting.
And one more question is, what is the material used to make stents? So what is the material used to make shunt?
Hello.
It is just a weak question. It is what is the material used to make stunts?
Can one of the industry people answer this? Because if you're using a biodegradable stent, I don't know the exact material you're going to use. Ravi Shankar, can you answer that?
I think if it's a conventional stent, which is just customized by 3D printing, you would use medical grade titanium because you need that strength. However, if you're going for bioabsorbable stents, then you have a new generation materials which are biomaterials, some of them even nano characteristic materials. That's where the research is going on. So in future, you can expect that bioabsorbable materials and self-degrading materials could lead to formation of stents. Today, it's still a little bit in research because the stents also need to have strength. And then it could even be that they also need to be drug eluting. So while drug eluting, bioabsorbability is already established. Combining that with strength is where research is going on, and you can expect some good results in the years to come.
Can we go with one or two questions, sir?
Yes.
Take another 1 or 2 questions. So, what is the downside of 3D printing, and are there any reported potential misuse of this technology? And what guidance is offered by the regulatory agencies?
Well, I think there are some research where metal, especially titanium, medical grade, is interacting with the surrounding tissues. When the patient goes for chemo or anything, any other radiations, there could be some trauma that can occur. So they have risk actually. And even otherwise, the titanium within the body, one Professor Ravi was presenting in a Coimbatore conference. It has so strong that body around it will become weaker, because you have a very strong another material. And so he was explaining the mechanism with and that is something which is very dangerous if it really happens. And I'm not sure industry or the clinicians, in their enthusiasm to actually take care and solve a problem, are they going to create a new problem? We don't know, because technology is always like this. So it needs some kind of a window period wherein we need to study the implants which have gone inside the body, what has happened, and if there is any revision surgeries that are needed, wherein for children, for example, it is routine for a revision surgery when you put a implant. Such cases will open up, what has happened, wherein it is not going to be reviewed again without any surgery. What has happened? Hardly anybody goes into check what is happening to it. Probably, I think that is one area where we need to look at, and this will in turn give rise to medico-legal cases. If there are any problem, like what happened with Johnson & Johnson implants. So technology, I think we should adhere to some of the clinical norms of testing, randomizing results, and working on the statistics. But there, in onco cases, for example, they're so unique cases. They don't occur every time. So they require patient-specific implants, as a only option to reduce the trauma to the patient. So the clinician will take a call as to what is the good management for that treatment. So I think our own understanding of using 3D printed anything inside the body has to be learned. I will say I will never. I don't know. We need to wait for the results, but there are early results coming. I've got few papers. I have one presentation on my computer, but of Ravi's, but that is his work. But I can share it. So it's a concern. Clinicians have to study it. And it is after all the research done by an engineering researcher with the clinical data. And I think again joining hands here would be a great opportunity.
Thank you, sir.
Thank you, sir. I think it was wonderful. And as Dr. Shyam Prasad Shetty was rightly putting it, co-creation is the rule of the current requirement, that doctors, engineers, designers, pharmacists, dentists, everyone have to join together, and certainly we can make a very good initiative under the SIG. I think we had enough of questions, Gaurav. If it is okay now, I think we should request our Director of Academics, Dr. P.A. Kushalappa, to give his concluding remarks. Yes, sir. Yes, sir.
Thank you, Pramod. I have had a very informative and educative afternoon listening to the experts, and my mind is full of what 3D printing in healthcare is. I am also, my knowledge is enriched with Dr. Guru Prasad and Dr. in forming the SIG, and of course my good friend Shyam gave me a lot of inputs into what's 3D and how easy he can plan his surgery. 3D printing is an upcoming field in healthcare, we all know that, and especially with the merger of medicine with healthcare and technology, it is one of the most progressively applied fields. So we heard about concept designing, preparing bioinks, bioprinting, and incubation. We heard about all this. And Dr. Because we thank, can I finish the vote of thanks also with this?
Yeah. Please, sir. Please.
So we thank Dr. Surinder Singh, our Vice Chancellor, for giving his inaugural address. Unfortunately, the words of wisdom from Dr. B. Suresh, our Pro Chancellor, he was preoccupied and he was busy with so many other things. So he was to highlight the importance of 3D printing in healthcare. And we missed you, sir. And of course, Dr. Pramod, you spoke well about the formation of your special interest group. 3D printing and fastest growing industry in the years to come, and I'm sure Dr. Guru Prasad and Ravi Shankar will vouch for this. And the technology and its use, as we have seen, especially during the COVID times, have been a rejuvenated promise that quick and accurate manufacturing is possible through this technology. We have seen how you adapted to the COVID times. From food to printing body parts, it's nothing short of a scientific fiction becoming reality. So I appreciate the efforts of Dr. Pramod, Dean of the Faculty of Pharmacy. Like I said, he established the special interest group and is taking this concept forward. The efforts of JSS College of Pharmacy and his whole group is commendable, and the work that has been taken up in this field by our faculty from JSS AHER, the students also in coherence with our industry partners, I should add, is the future pathway for 3D printing technology in healthcare, especially in the pharma sector and the cosmetic industry. And we wish you all a successful path of discovery and invention. Pleasure to listen to you, and hope the ideologies of co-creation and learning will take us a long way. And we thank you for an enriching talk, sir. And the way you answered most of the questions of your experience while through various implants, that was very good, and it was candidly shown. I'm sure that the participants would be eagerly thrilled, as all of us are. And so Ravi Shankar, Managing Director, Accurate Labs, you highlighted the serving patients and doctors during COVID times. And I'm sure the applications which was shown was very educational. And it is beyond words that such a work was undertaken, which integrated the lives of many during the global pandemic. I thank you, sir, for a wonderful seminar on the application of 3D in COVID times. And Dr. Shyam Prasad Shetty, our cardiac surgeon, you spoke so eloquently on how 3D printing helps cardiac surgeons in preparing themselves before a complicated surgery, as 3D printing can replicate the actual condition which you are going to face, be it heart surgery, stenting, or a valve replacement, including you spoke about cancer resection. Thank you very much for the heartening talk which you gave, and your response to the questions which were thrown to you. And finally, Pramod, I'd like to add that I was very happy to hear that you are going to get this into a documented form, and you're thinking of publications and projects, this special group. This SIG is going to have a lot of outcomes, I'm sure. And in conclusion, I'd like to thank Gaurav for a very, very wonderfully compared program, Gaurav. And thank you all for that. Thank you very much, sir.
Thank you, sir. Thanks for all the support from the university that you have been giving us.
Always
and with a wonderful smile all the time, which we try to always go with. So I thank all the panelists for sharing their information, and let us go ahead and in co-creating these things, be it in terms of project proposals, articles, or wish to have a center of excellence.
Thank you, and
once
all the
again.
best.
Good day.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye. Bye-bye. Bye. Bye.